Okay, yes, we are live. All right, well, welcome to Hadoop Puzzlers. So before we get going, let me just say a little bit of housekeeping, just make this really clear. So this talk is in the admin track. That's maybe not exactly the best home for it. If you actually read the description, you see this is going to be a very code-heavy talk. If you didn't read the description and you just saw admin track, Cloudera, cool, be warned, lots of code. Right, and this is going to be a little bit more end-user focused than perhaps a classically admin-oriented talk. All right, here's the clicker. All right, let's get this thing going. All right, so let's start by introducing ourselves, and then we'll get into what we're doing. So let me first introduce my brother, ATM,
hey.
or as Mama likes to call him, Cash Money. So he is one of the illustrious software engineers at Cloudera, and also a member of that exalted inner circle known as the Apache Hadoop committers.
Ooh.
Yes, come on, give it up, yeah.
Yeah, and this is my brother Daniel, aka DTemp is what we call him around Cloudera. He has been working on distributed computing longer than I've been alive, at Sun before this, and now at Cloudera, and he is one of our illustrious certification developers at Cloudera.
Word.
Ooh. Okay, all right,
yeah,
cool.
so if you take the Java developer certification and you don't pass, that's my fault. You're welcome. All right. All right, so Hadoop Puzzlers. So anybody who's old and crusty like me remembers from the Java 1 days a talk by Josh Block that they did over and over again. Josh Block, Neil Gafter, and various other guests called Java Puzzlers, where they would basically put up source code that's really obvious what it does, but that's not right. Right? And I thought, hey, that's cool. It kind of relates to certification. Let's go do a talk about that for Hadoop Summit. And kind of one of the bonuses of this format is, so not only was Josh able to turn his Java Puzzlers talk into a long series of a talk every year at Java 1 for, I don't know, 5, 6, 7 years, he also got a book deal out of it. So if there's any publishers in the audience, feel free to come up after us and talk to us about a Hadoop Puzzlers book. We'll be here.
Happy to do it.
Yeah.
So what's the structure of this talk going to be like? We're going to present you a puzzle. We're going to mostly code or maybe a Hive query here and there. And it should be just patently obvious what this thing does. One of us is going to try to figure out what it does, walk you through that. And then we'll find out what it actually does. And it might not be the obvious thing. You guys will vote on the answer. And then we'll see. Yeah,
and audience participation is required. We have a herd of wild pigs we will release into the audience if we don't get enough participation. So
yep.
Like, you guys, we're going to vote by hand raise. So
you all have hands?
Do you all know how to raise your hands? Yes? Okay, about a third of the audience knows how to raise their hands. All right, cool. And, and afterwards, hopefully we learn a valuable lesson from this. There'll be group hugs if you need it, maybe a group support session or something. All right. So why don't we give it a try? And why don't we start with an easy one? You want to start?
Please.
All right, so here's one for you. And here's a laser pointer if you want to.
Let's see what my brother Daniel has for us. All right. OK, it's a MapReduce program. We got our little mapper and our reducer. OK, pretty straightforward so far. Let's take a look at our map function. That's a good place to start with a MapReduce program. So we're taking a long writable and a text as input. Let's see, the value, we're just going to split that on commas. Nothing too sinister yet. OK, we got 2 parts down here. The first part and the second, if there's any parts after that, hopefully we have commas in these lines. And if there's more than one, I guess we just discard it. And then we write out the key and the value. All right, mapper, pretty easy stuff. OK, let's look at the reducer. So it's going to take a key. Yep, text key. And then, right, we parsed it as an int. We're going to get a list of integer values here. OK, all right, we've got our little max here, so we're going to keep track of that. We're going to iterate over the values. And if the current value is greater than our current max, then we set a new max. All right, easy stuff. This MapReduce job is going to find the max value in this job.
So it's going to find the max value overall?
Yeah, I mean, obviously.
Oh, or per key?
Oh, so per key, we're going to find the highest value and output that.
All right, so let's give you some data, and let's see what you think the results are. So here's our data.
OK, over here, A1, A5, A3. All right, we got commas in all cases, 1 comma. All right, good stuff. All right, so based on my read, let's see, we got A here, A5. That would be the max. A1, I don't see how A3, that's the last one, but still not the max. I don't think the job fails. That would be mean of you. That would be really mean of you. I don't think.
I am a little mean.
So I'm going to go with A5. That's my answer.
All right. So what we're going to do is we're going to put the code up here for just a second with the data. You guys take a second. Take it all in. We're going to go back to vote in just a second. All right? You got it? You think? Do you agree with this read of the code or not? All right.
I'm a Hadoop committer, people.
Yeah, he's a Hadoop committer. How could he be wrong?
Okay.
All right, so let's go take a vote. So who here, remember that raising hands thing about a third of you know how to do? All right, who here agrees with my brother that the answer is A5, that this is what this guy's going to output?
Good. Very good.
Believe the Hadoop committer.
Very good.
Good call. All right. How many people think that it will be B, A1?
Okay.
A couple.
Handful of people.
A couple brave souls. All right. How many people think it's going to be A3, C? Yeah. We've got a handful. All right. A little more than B. And who thinks it's going to fail, that I'm just a sadistic SOB? Yeah. Yeah. Okay. Is this because it's going to fail or that I'm a sadistic
I could guess
SOB?
that too.
Yeah. Right.
Yeah.
Okay. So let's see what we actually get. The answer is C.
No, come on.
The output is A3.
That doesn't make it. That's not the max.
Yeah, no, it is
Come
not
on.
the max. All right, so let's look at what's going on here. So you can see I've highlighted some code in purple there. I've highlighted two things. So we are indeed going through and finding the max, but we are storing not the value of the max, but the int writable that is the max. Now, the problem with that is that Hadoop is super efficient. And when you go through that for loop over iterating through the values, it is going to give you the same int writable every time. So when you store that int writable in the max, every time through the loop, that int writable's value is going to be changed.
Oh.
So in the end, what you get is the last int value as opposed to the maximum.
Those pesky references. All right.
Yeah, indeed. You thought references were only in C.
Okay.
All right.
All right.
So here's your moral from this story. So MapReduce is going to reuse its writables whenever it can. It's going to try to do this for scalability reasons, particularly when you go iterate through the values in your reducer. Be aware of this. This is one of those things that generally bites new MapReduce programmers, and it takes a while to figure out what the heck's going on because there's no obvious tell. It's just completely misbehaving for no apparent reason. Right? So always, always, always only store the value, not the writable. Right? And that goes for text as well, because text is writable.
Very sneaky.
Yeah.
Very
all
sneaky.
right.
All right, you up for one?
All right, hit me.
Okay, that was sneaky.
All right.
See what you got here.
I have a sinking feeling about this. All right, so Async Submit is what this job's called. So I'm looking at this guy. First of all, this is all driver code. I don't see any mapper or reducer. So let's see what the heck we got. All right, so we've got a main method, tool runner. OK, that's all really boilerplate. So we look at our run method. So this is what our driver code's going to do. All right, so we've got a job get instance from the configuration. That seems reasonable. So we've got our job. We say no reduce task. So this is a map-only job. So that's why there's no reducer. All right. We add our input path with args0. We add our output path with args1. Really super boilerplate. And then we say we want to run the job, and we're going to set wait for completion to false. OK, so it's going to be an async commit, or async submit, rather. And then we're going to return this, let's see, job is complete thingamabob. All right, so it looks like what we're doing here is we're returning 1 if the job is complete, which kind of makes sense since Unix is has the standard that you return 1 if there's a problem, and this is async, so if the job isn't done yet, or if the job's already done, I can see where you'd want to return 1 and say this is a problem, and 0 if it's not complete, which is what it should be. Now, I have a problem here. There's still no mapper. Right? There's no map class defined here. And there's also, there's this job.set jar class package. There's something that you're supposed to do with your class file to set your jar that my IDE always auto-completes for me, and I don't remember what it is exactly, but it's missing here. Right? So this doesn't look very good to me. So let's see. Show me what my options are.
Okay, what do you think?
All right. So the data, OK, our old friend, the complete works of Shakespeare. So if you've ever taken any Hadoop class from any vendor ever, you hate William Shakespeare. So this is our data and our results. So I didn't see anything that looked like it was going to fail to compile. But I'm thinking we might fail. If we don't fail, we're going to exit 0 because we're doing the async submit, and you get a 0 if the job's not done. Or exit 1, which would mean that it was not an async submit. I'm really bothered by that MapReduce, by that mapper not being there, and especially that set jar path class thing, whatever
Why would
it
I
is.
do that?
Yeah, I'm going to say job fails. I'm going to say the answer is B, job fails.
OK. All right, good guess. Take it in one more time. Remember, the input here is the complete works of William Shakespeare, pretty large. Guy had a large vocabulary. OK. So vote real quick. Who thinks that the job fails to compile? That I'm a real jackass and that there's some semicolon missing? Anyone? Yeah, I'm not that mean. All right. Who thinks the job fails? Who agrees with my brother that the job does not succeed? All right, 1 person, 2, 3.
Hey, I'm a certification developer,
OK.
believe me. All right.
All right, who thinks it exits with 1? We asynchronously submitted.
Exit 0 first.
Exit 0, excuse me. That it, OK. All right. And who thinks it exits with 1, that somehow Shakespeare's works are very small? OK. OK. Exits with 1 is the right answer. Good work, everybody. Why on earth would that be? Brother, what if I told you that that little set wait for completion is not set wait for completion, false. It's actually just always wait for completion.
Well, that's a horrible
and maybe
thing to
do something else. So it's actually always wait for completion and then optionally output status information or don't. That's what that Boolean parameter does. Ugh, sorry.
But I did this with the autocomplete on my IDE.
Yeah, I know you did.
Okay,
I know you did. And your IDE is great, whatever it is. But it doesn't behave exactly like you wanted. So
NetBeans.
yeah.
Okay.
So like I said, the driver does wait for the job to exit, unlike what you thought. But it does not print job status. That's a pretty unfortunate job.
So basic is wait for, or don't trust your IDE's autocomplete. Actually read the docs. Go figure.
That's the moral of the story here.
All right, cool. You ready for another one?
Please, yeah, let's go.
All right, so this one might look familiar.
Can you get that?
Oh, take that, yeah.
Thank you.
This one might look a little familiar to you.
OK, got it. So all right, looks like we're trying to get the max value per key again. All right. OK. The mapper here looks suspiciously similar.
It is suspiciously
You're going to give
similar.
me that it's the same?
Identical to the last one.
Thank you. Thank you very much. OK, so I'm going to focus on the reduce function then. OK. So again, we're taking text key, iterable values. All right, we fixed our little bug here. Now we're storing actual values, not writables. Gotcha. You sneaky. OK, all right. We're iterating over the values, and we're only looking at the actual value, not the writable. OK, no sweat. This one works. I'm confident this one will get the actual max value per key and output that. Yeah, there's nothing wrong here.
All right.
This is going to be a boring
You're the
one.
Hadoop committer. You should know.
Right.
All right. So let's look at some data. So your data's a little easier this time even.
OK, so we've got just 2 entries, A1, A5. We output them. There's only 1 key in this data set. We're going to output the max value. That's 5. So A5. So my answer is going to be A, A5. So B, A1. Do I think somehow it's doing the exact opposite of what it? No. A1, A5. It outputs both somehow. I don't. No, we're only outputting 1. That function is only outputting 1 value per key. And I don't think the job fails. We're going to stop bunking together if this job fails. Right. OK.
Fair enough. All right, so you were sure that it was A5 last time.
I'm positive.
You remember that? OK.
You can have my salary for a year.
All right. They're video recording this.
OK. All right.
All right, so give you guys a chance to look at this code again. Your data's up in the corner. Have a look. See if you agree with my illustrious brother here in his certainty that the only answer can be A5.
There's no question.
Yeah. All right?
Depends on the job comp, says Alan.
All right. Let's look at our answers. All right, so who agrees with my brother that the answer is obviously A5? Yeah, all right, they're getting smarter. All right. Who agrees or who thinks it's the opposite of that? It's B, it's A1. Nobody. Ooh, all right. Who thinks the answer is C, A1 and A5. A decent chunk.
Like
All right,
30%.
so I'm guessing then everyone else thinks the job fails, yeah? Who's for job fails?
Yeah. No, this
Yeah,
job
all right,
is not,
that's
yeah.
okay. Of the third who have hands, yes, that looks like it's about it. All right, so let's see what actually happens. The answer is A1 and A5.
Why on earth? That doesn't
Why
make any
on earth would this be happening?
That doesn't make any sense.
All right, now it doesn't make any sense, and I actually spent about an hour chasing my tail over this one once upon a time. So you notice I've highlighted very little here, but it's very important what I've highlighted. So the signature of the reducer that you are extending does not match the signature of the reduce method. So what happens is...
Okay.
What happens is you get the base class's reduce method that does match the signature, and the base class's reduce method is an identity reducer. So it just passes through everything it sees.
We might be brothers. We're not friends. We're not friends anymore. Okay.
So there is one little thing that you could have done to have saved you, and I could have done to have saved me, the hour of time going through this bug, and it has to do with letting your compiler help you. So the moral of the story is always use @override. Right? If we had remembered to put the @override in front of that reduce method, when we went to compile, the compiler would have said, "Oh, what you talking about, Willis?" Because there would not have been anything for it to override because the signatures didn't line up. If you leave that out, the compiler can't help you. You're on your own. Dumb things like this happen. You chase your tail. You feel dumb at the end.
And I do. Okay.
That's my job. I'm here for you.
You up for one?
Yes, absolutely.
That was mean.
All right.
What do you say? How about a hive one? How about a hive one?
Okay, cool. All right, so we are switching gears here. We're going to do some hive. Oh, goody. Let's see. I'm just going to go with my SQL skills here and bluff my way through the hive. All right, so looks like we've got describe table 1. So it looks like we've got first table. It's got an int ID, a string phone, and a string state. We've got a table 2, which has an int ID, a string city, and a string state. So all right, so I see ID, state, state. We've got some redundancy in our data. All right, so now, oh geez, we've got some kind of statement here. So let's take this piece by piece and see what we get. So create table 3. All right, we're creating a new table. As select of everything from table 1 or table 2, plus the phone from table 1 and the state from table 1, and we're going to join table 1 to table 2 on the IDs. Oh boy. All right, so. So we know because we've got table 2 here and we've got everything, we've got an ID, a city, and a state, and then we throw in the state again from table 1. So we've got 2 states, and that's probably not a good thing. I see this here, which I guess is to keep Hive from choking on that when you're writing the statement. Now I notice you very generously removed the bit here that says whether this statement is passed or succeeded or failed. Thank you for that.
Happy to do it.
Okay, so all right, let's go on. So then we're going to export this table to a CSV file in the user Cloudera account, because obviously that's the user account you'd be using. And then we're going to, and again, no success statement here, no OK or not, thank you. Then we exit Hive, and then we do this really ugly Unix command line thing. Let's see, so we're going to cat table3 CSV, which we don't have to say the directory because it's in our home directory. Okay. We're going to take the first line of it. We're translating all of the commas to new lines, and then we're doing a word count, or a line count. So let's see, it's a CSV, so translating the commas to new lines of the first line is going to give us a line for every field, and then we count them. So all right, so this thing at the bottom looks like it's giving us a count of the columns, which goes back to begging the question of what the hell does this do? So we've got 3 fields here and 2 fields here. And the question is, does this state thing work out or not? I don't know. Let's see some data, and let's see how we do. Yeah. All right, so looking at our data from table 1, this data all looks really sane. So this was the ID, the phone number, and the state. No commas in here. He's not being that mean. Looking at table 2, again, this looks pretty sane. ID, city, and state. And choices. The choices are we going to see 5, 4, 1, or the join fails? Oh, boy. Well, join fail seems like a cop-out to me, right? What would we learn from just saying I can't write good HiveQL? So I'm going to say it's got to be one of the top 3. It's not 1. It's got to be 4 or 5 because the question is that state thing valid? And I'm going to say because we renamed the table1.state to S, I'm going to say it actually comes through, and the answer is A.
OK.
That's my final answer.
OK. All right. One last time to ingest this. Here's the query. Here's the data. Everybody think hard about what the right answer. How many columns are going to show up here at the end? OK. And let's vote. All right. Who thinks the answer is A? There's going to be 5 columns. We end up with all the columns from all the tables. All right.
Oh, come on,
OK.
people.
A handful of people.
Give me more credit than that.
OK. All right. Who thinks it's B? Who thinks that Hive handles those join rules right? We're going to end up with 4 columns. OK. All right. Who thinks it's C? Somehow we end up with 1 column. All right. A handful of folks. And who thinks that the join fails and we should be kicked off the stage?
Well, all right. So separate those.
OK. Who thinks the join fails? OK. All right. I can't write Hive.
No.
I'm not a Hive committer. OK. The answer is C, 1. What?
What?
Why would
one
that?
wasn't an option. One was the only one that wasn't an option.
One should have been an option. What if I told you, brother, that it was really cute that we put .csv at the end of that file name, but it's not a CSV?
Oh, wait.
What if I told you that?
Wait, so Hive, so when I say it's a CSV, Hive doesn't just know?
No.
It's not reading my mind.
That's Hive 14. Hive 14
okay. Right.
will know and be able to read your mind. There's a Jira. No, unfortunately, the default delimiter is not a comma. It's Control-A when you export a table from Hive. So you got I'll be honest with you got the right number of columns. Hive you were right there. Good work. But that little Unix command line, that little tr replace commas with new lines, no dice there.
No.
Sorry. So the moral of the story here is don't assume. Again, Hive does a good job with joins. It picked a kind of funny delimiter by default. All right?
All right. Excellent. All right. So revenge is sweet.
Bring it.
Just remember that.
Let's go.
All right. You ready?
Please.
All right. This might look familiar.
OK. All right. No sweat. I've got a handle on this now, right? Yeah. OK. So this mapper looks, again, pretty similar.
It's same thing.
It's the same? You
mapper.
wouldn't be lying? All right.
Yeah.
But this reducer is different. Let's see. OK. We got the signatures right this time. Should have put in the override. Come on, what are you doing? Anyway.
Too much confidence.
OK, top 20 reduce. All right, let's take a look at this. We're dealing with floats now. OK, for some reason, not quite sure what yet. We're going through the list of values, and we're keeping track of the max, just like last time. Maybe there's a casting thing there, ints, floats. I think that'll be OK. After we're through all the values, let's see, what do? We multiply the max by 0.8. OK, so 80% of the max. OK, we reduce our max by 80%. And then we're going to go through the values again. And if the value is greater than or equal to max, then we output. OK, so we're outputting, for every key, we're going to output the max value and all the values within 20% of that. OK. Yeah, sure. All right, this makes sense. This works.
Yeah. All right. You confident on what it does?
I am confident on this one.
All right. You were confident last
Let's
time.
see some data.
All right. Let's look at some data. All right. Here's your data. This data might look familiar.
A1, A5, A4. All right. One key again. This is getting OK. I should be able to get this. OK.
You'd think you'd get one. Yeah.
Yeah. OK. So based on my read, let's see. The max is going to be A5 for this key, and then we're going to have 4, which is OK. So that's exactly 80%. It said greater than or equal to. So I'm pretty sure the answer. OK, yeah, all right. So let's take a look at the possibilities. So first is that we output nothing. Is that a typo?
No. It's nothing.
OK, that doesn't make any sense. Let's see. A5. OK, that's the max. That's straight up the max. But this is a different reducer. It's not going to be that. It's going to be A5, A4. I'm pretty sure. I don't think the job better not fail. It's C. It's C, A5, A4.
We've not had a job fail yet.
That is true. That is true. Maybe we're due for a job fail. OK. Now, it's C. It's C.
Right.
A5, A4.
You're sure?
I am sure.
Do I get you next year's salary?
Oh, gosh. Sure. If I can actually live at your house. Yeah,
all right. Let's see. All right, so guys, this is your opportunity. Cozy in. Have a read. Have another look. There's your data. There's your code. Take a look. I'm going to mosey over here and check my time.
OK.
How are we doing? This is what time it is. All right. Okay.
OK.
All right. You guys feeling confident? You know what the answer is? Is confident as my brother?
I'm confident.
All right, he's confident, for what that's worth. All right, let's look. So, who votes that the result is A, we get nothing? Whoa, overwhelming majority.
You guys are not Hadoop committers.
Who votes that the answer is just A5, which looks like maybe there's some kind of float funniness going on there? All right, a handful. Who agrees with my brother? The crickets. Oh, no, OK, there's a couple.
Come on, I'm going to get one right.
All right, and who says the job fails? A couple. OK, so no, you guys really underestimate our level of cruelty, I have to say. You happen to be right this time. So the answer is nothing. Now, someone, so this is, it's time to step up the audience participation just a level here. Someone who voted for this, for nothing, why nothing? You can't iterate twice. Thank you, sir.
I wish I'd known that. Okay.
This was, I taught a Hadoop class not too long ago, and one of my students spent an hour going over this. So his point is, this code down at the bottom, this highlighted code, does nothing. It does abso-smurfly nothing. So you're able to iterate through the first time. Everything works as, by the way, sorry, I have to interrupt myself. I feel really, really bad about having put code that looks like this up on a screen, and I have to just go on record as saying, this is horrible code. If you ever write this, I will personally come find you and hunt you down, right? Put the frickin' braces in here. Do not stack infinite, right? But to squeeze it into a slide, you do what you got to do. All right, so back to what I was saying. This works out really well. You're able to iterate through. You're able to get your max. I've got a pointer here, too. I thought. Anyway,
maybe not.
You're able to get your max and store it, and all that's handled correctly. And then you get down here to this second for loop, and it's empty, and so you do nothing. And you skip over it entirely, and you output nothing. So
you guys are smarter than I am.
Yeah, good reasons. So what's going on here is, again, Hadoop, for scalability reasons, is trying to be clever. And what it's going to do is give you a single-shot pass through that iterator. And when you get to it the second time, it's just going to quietly be nothing. And there's going to be no flags, no warnings, you're going to get nothing. And you're going to wonder why you've gone insane, because obviously there's something, right? So this is a good one to chase your tail on.
Yep.
This is a nice, subtle one.
Hurt your head, hurt your keyboard.
Yeah, exactly. So you want to store the values, not the writables, right? We learned that in the first one. We don't store the writables. Store the values in the first pass, and then go through whatever collection that is if you need to do that. That, however, itself is kind of an anti-pattern, in that now you're taking all of those values, which could be potentially enormous, and loading them into memory, which may simply be a horrible thing to do, and in often cases is, in which case you just kind of need to restructure. And what you're probably going to find when you go to restructure is that you're no longer going to be able to get away with just one job. You're going to end up chaining jobs so that you can not have to load everything into memory to make this work.
OK.
All right?
All right. Very educational, brother. Thank you.
That's what I'm here for.
Thank you.
Yeah.
I got one for you now.
Oh, great.
You ready?
OK. All right. Hit me.
OK. Let's take a look at this guy.
Overbite. All right. So we've got, all right, so this is, hey, I get a MapReduce job finally.
Yeah.
Thank you. You were hoarding them.
Sure.
All right. So we got a mapper. We got a reducer. We'll assume sane driver code. All right, let's check. OK, so signatures line up, long text, long text.
Yeah, I'm not that guy.
Iterable text. Oh. All right, so looking at our map method, we take our value, we convert it to a string, we get the substring 0 to 1, which I think is going to be the first character, and we make that our key. We then output the key, which is the first character, and the value, which is the whole string. All right, so it looks like our mapper is just giving us all of our input indexed by the first letter. So in our reducer, what are we doing? We start with a min set to integer.maxValue, which is a pretty reasonable thing to set a minimum to when you're starting. And then we're going to iterate through our values. And we're going to say for each value, let's get the bytes that represent the string. And then of that array, let's figure out how long it is. And if it's less than our minimum, which is starting out at the maximum, we're going to store it. OK, you could conceivably save yourself a couple of method calls by sticking this in a variable somewhere, but that's no big deal. And we're going to write out the key, which is the first letter still, I believe, and a new int writable around this minimum. All right, so it looks like what we're doing is we're indexing every line by the first letter, and then for each first letter, we're going to output the length of the shortest line. I think that's what we're doing.
You got it.
Is that what we're doing? There you go. See, and I get one right. All right. All right, show me some data.
Yeah, what do you think?
All right, so we've got data. We've got Hadoop, which is 6 characters, Spark, which is 5, Hive, which is 4, and Scoop 2, which is 6. So we got H6, S5, H4, and S6. All right, so our choices are, let's see, we could output H4, which would be Hive, the shortest, and S5, which would be Spark, which would be the shortest. Sounds good to me. We could output H6, S5, which would be Hadoop, which is the longest H, and Spark, which is the shortest S. That seems somewhat mixed. We could put out C. Let's see, this is H6, which is Hadoop, which is the longest, and S6, which is Scoop 2, which is the longest. So this is doing the opposite of what I say it does, and I'm obviously correct. He said so. Right. Or the job fails. I'm going to go. I'm going to stick. I'm going to stay with my guns. What the heck is that phrase? I'm going to stick to my guns. There it is.
Still no job has failed.
And you would know.
No job has
failed yet. You're right. I'm going to go with this. I'm going to say it's A.
Okay.
I'm going to say the correct answer here is A.
I think that's a good read. All right, let's let you guys look at the code one more time with the data. All right, we've got Hadoop 6, Spark 5, Hive 4, Scoop 2 6. All right. Everybody got this?
You didn't do something funny with the substring or something.
Yeah, no. OK. Who thinks it's H4 S5? Who agrees with my brother here?
I mean, obviously.
Come on, we're going to get one right, right? No? OK. All right. Who thinks it's B, H6 S5? Somehow the logic's mixed there. All right, 4 or 5 people. OK. Who thinks somehow it does the exact opposite of what my dumb brother thinks, and it's C, H6, S6? Who thinks that? OK.
Pretty good turnout.
All right, good. And who thinks the job fails? We've finally done it to you. OK. 1, 2 people.
You really
3. All right, good stuff. What if I told you the answer is the one that doesn't make any sense at all? B, H6, S5, somehow it's mixed.
I think that's the theme of this presentation. The answer doesn't make any sense at all.
What if I told you it was that one, brother?
That doesn't make any sense at all.
Okay.
That's what I would tell you.
OK, what if I told you, furthermore, that though it's really good that I was not storing a reference to the writable, we're storing the actual minimum value, that not only do we reuse writables, but those writables might reuse their underlying byte arrays if they're big enough.
That's just sick.
I know it is sick. It is sick, something only a sick person would do.
Like you.
But that is what some Hadoop committer did.
Committer, yeah.
Not me, but yeah, somebody. So the trouble here is that the byte array, let's see, can we look at the data again? The byte array for H, the first byte array that's allocated for H, is 6 characters long, OK? And the byte array that's later allocated for Hive will fit into there, so we don't allocate a new byte array. And recall that the code is just looking at the bytes, the size of the byte array. Whereas Spark is actually, the first one, that's 5, that's shorter than Scoop 2, so we allocate a new byte array. That one's longer. All right? So what's the moral here? Writables get reused in all sorts of ways.
You're just a sick puppy.
I am a sick puppy. For performance reasons, writables get reused all over the place. In addition, text, as a writable, internally will reuse its own internal representation of a string in there, and thus not reallocate a new byte array for you. The net result is bad values, but it's very fast. So the right answer here would be to use .getLength. Don't use .getBytesLength. Okay, text keeps track of the actual length of the string that it's
Well, that's
storing.
convenient.
That is nice.
It'd be nice if my IDE autocomplete had told me.
Yeah. So that's the moral there.
All right.
Got it?
Got it.
Okay.
That was, yeah.
All right, let's do a quick recap, what we learned.
Yeah, all right, so
What did you learn?
here's what I learned. I learned beware of, well, actually, I learned that you learned, so this is actually the lesson you learned, right,
Sure.
is beware of writables, right? So writables get reused. Writables do funny things under the covers. There's a lot of stuff that goes on with respect to writables. Be conscious of them. Be aware of them. Dig into them deeply. Be gentle with your writables.
Yep.
Yeah.
Yep. I'd say the other big lesson, always use override. But in general, it's like check the simple stuff. If it looks like your reduce function's not getting called, maybe it's not getting called at all.
Yeah. Well, and to expand on that a little bit, right? Like, do anything you can do to help. Let your compiler help you. Help me help you. Right.
Yeah.
Add override is a great thing, and this goes beyond Hadoop, right? When you're writing code. Add override everywhere. There's a reason why your IDE underlines it with a little yellow squiggle if you're using NetBeans, because NetBeans is the only one and true IDE. Can you tell I worked at Sun? All right. So big takeaway for me in Hadoop in general is don't assume you know what's going on just by looking at stuff. There are things that are so obviously named as to what they do that
wait for completion.
That what they do has nothing to do with what they sound like they do.
Yeah.
Right? Read the docs. Now, here's the problem. In a lot of the docs are merely just a method signature, right? The Java docs don't actually have any meat to them. When that happens, go read the source code, right? Like go
and then submit a patch to fix
and then submit a patch. Yes, document it yourself. Submit a patch. He'll commit it for you.
There you go.
Right, but go read. Don't assume. There are a lot of cute little things that will bite you if you just assume that they do what you think they do.
Yep.
Right? Double check. Stack Overflow is your friend as well.
Yep. And then I'd say, finally, sometimes scalability messes with stuff, right? The whole point, like a lot of the things that you saw here, Hadoop does very deliberately. They're not bugs. But it does kind of mess with what the obvious meaning of these things is. And that's sort of the nature of the game. You want it to be fast. Hadoop does some things for efficiency that might not be super obvious. All right?
All right. So one closing note. So did I mention I'm on the certification team? So I'm going to rant just a smidge on certification, which is to say that Hadoop is still really not easy. Right? Hadoop gets easier. Things like Hive make your abstractions better, but if all you know is Hive and you don't know what's underneath it, you're still going to run into all kinds of funky issues. Right? It's hard to know. It's hard to develop the skill set to be good at Hadoop and to have guessed all of these correctly. I mean, hey, we work for Cloudera and we got them all wrong. Right? It's even harder, especially as a manager, to know if someone else knows what they're talking about in this space. Right? It is very challenging to recognize proper Hadoop talent. So one of the things that we're doing, and I apologize for the advertisement, but this is what I do, and I think this is really important, and it's a message worth sharing, which is that we are trying really hard through certification to make it possible to look at somebody's resume and go, oh, they're certified. They actually know what they're talking about. You will see coming in the next few months a revision to most of our certification processes that's going to make them a lot more interesting. You're going to see things like you have to actually write code to be a developer, a certified developer. Go figure. Right? So that's my advertisement. Advertisement's over. You can flip to the end, and we have about, I don't know, a minute 38 seconds for questions if anybody wants to ask something. Or if you just want to stare at us in dazed confusion, that's also really cool, because that's what we're going to do.
Or go get a coffee.
Yeah.
Any questions at all?
Anything.
Question.
Do you guys collect these and post them somewhere? Because those examples were interesting. I'm sure working at Cloudera, you've run into other interesting things that customers have asked you. Like,
Sure.
is there some space where I can go and read 100 of these?
Sure. So I'll repeat the questions. The question is, do we post these things anywhere? Can we read 100 of these? No, not yet.
Not
but
yet.
Maybe
Are you
we
a publisher, perhaps?
Yeah.
No.
There'll
Okay,
be a
no.
book. There'll be a book in 8 years that'll just be chock full of these. No, we don't. I imagine the slides will be posted. I don't think we have a collection.
Yeah, no.
of these.
Yeah, as far as I know, there's no collection of these sorts of things. This is snippets of wisdom. So I have on my whiteboard at my office, I have about a dozen or more of these things that that we picked these from. But I know of no compendium where these are collected, except, so I will tell you, like, for example, that really sadistic one about Hive CSV export having only one column thing, that comes off of the data science certification. Right? I actually asked that question on the certification. So some of these are actually, they're documented in the certification. So if you go take the certification, you have to answer questions like this.
And if you come up with them, you can email them to us.
Yes.
You
Yeah,
know,
please do.
And we'll give you thanks in the book. So it's
Yes, right.
ATM at Cloudera and Daniel at Cloudera.
Yes, indeed. All right, we got time for 10-second question. There was one right here somewhere. Yes.
So I took the developer test and I failed. So now I know the reason why. So, but I was able to get through the admin test. So anyways, so the story is when we go to CDH5, is this administration test or developer test going to change to 5.10 or something?
So,
or it's going to be the same?
So the question is, in short, will the certification test update when CDH5 goes through? Yes, we are updating it to take out all the references to task trackers and job trackers and make it all yarnified. Other than that, there's not much that changes, right? If you look at the APIs, there's not a significant amount at the baseline that changes between CDH4 and CDH5. But yes,
it's better under
we're
the hood,
updating it.
But, yeah.
All right, and I think the shepherd's hook is going to come out because we're 30 seconds over. Thank you guys.
Thanks,
You've been
everybody.
awesome. You've been awesome.
Good work, brother.